Good afternoon, geometry. It's Maze. It's Thursday. And here's section 4.5 out of your geometry, dilations. So, what does a dilation do? It is a scale model of what you started. It's either bigger or smaller depending on the K factor. Okay? If K is greater than 1, the object gets bigger. If K is between 0 and 1, the object gets smaller, and K can even be negative, and we'll show you an example of that too. All right, so here's the whole concept of a dilation here, and here's your text. It's page 208, and they talk about the core concept here is a dilation. And as you can read, the key thing here is a center of dilation. Okay, that's point C here. Okay, and notice that the lines, if you look at the blue and you go to the red triangle, notice the lines that come off of C. All those points are lined up. R and R prime, P and P prime, Q and Q prime are all lined up with that center of dilation C. And then the scale factor determines whether it gets bigger or smaller. And again, if it's negative, same thing, only we're going to see that it is flipped over. Okay, so here's the concept of dilation. So if I start here, and I know that a lot of you have played with a flashlight and shadows. And if you put a flashlight here, and if you move something out and out, the shadow gets bigger and bigger and bigger. Okay, and here they have a scale factor. Notice it's the length of the whole thing over the length of the part. The length of the whole thing over the length of the part. That determines the scale factor. Okay, it's kind of an important concept. All right, here's your coordinate rule for dilations. If the point X and Y is the pre-image to the point, then it's image after dilation, centered at the origin, 0, 0, and all of my examples will use the origin as the point P. Then the scale factor is P prime is going to be some value times X, same value times Y. Okay, and we'll write it like this. XY goes to KX, comma, KY. Okay, so here's an example here where I doubled it. And that is kind of what I'm going to show you in my example right here. So here it is. I start off with triangle ABC. Now I've already got all my lines in here, but here's triangle ABC. And there's my points. And I'm telling you that I'm going to take XY and I'm going to double it. The scale factor is going to be 2. So basically you take A and you multiply the X by 2 and you multiply the Y by 2 and that becomes A prime. B, take the coordinates of B, multiply B times or the X times 2, multiply to 6 times 2, and that becomes B prime. Go to point C, 5 times 2, 7 times 2. Now graph those points, okay? Now notice here that A prime landed at the same point as B. And if you look at the two triangles, and notice that from P, it fits, okay? And that this image is twice the size of this image. So in other words, the distance from A to B and the distance from A prime to B prime, okay, this is twice this distance. This is twice that distance. This is twice this distance. That's what the K factor does for you, okay? Now, what happens if it gets smaller? Now in this case, I started off with a big triangle, ABC, and I'm going to factor it down by a factor of 1/3. So what I'm looking for is a triangle that is only 1/3 the size of my original. Okay? And that's kind of what I got going on here. So A to A prime, if you take 12 and divide it by 3 and take 6 and divide it by 3, B, if you take 6 divided by 3 and 12 divided by 3, becomes B prime. And C, 18 comma 9, becomes C prime after you divide both those by 3, 6 comma 3. Now if I graph those 3 points, I get my little triangle, ABC, but knows A prime, B prime, C prime. And once again, if you start at the origin, that's my point of dilation, and if I draw lines out here, and compare this, notice that everything is in line here. It fits this ever-increasing cone or this triangle here, okay? All right. Now what happens if K is negative? K can also be negative, okay? Now here, k factor is going to be negative. I'm going to let k be a negative 1/2. So in other words, every x and y is going to get cut in half and then negative. Cut it in half, negative. So let's see what that looks like. So here's my original triangle, ABC. I drew it out here like this. There's ABC. I've already put all the lines out here to show you how it really works. Now, when you take the k factor of negative 1/2, 2 comma 4a goes to a prime, negative 1, negative 2. B, 6 comma 2 goes to b prime, negative 3, negative 1. And c goes to c prime, negative 4, negative 4. Now, when you graph that, a prime, b prime, c prime, and draw this, notice what happens. This is now half of this. This is now half of this. And a prime to c prime, a to c, is half of this. Now notice that if you were to reflect this about the y-axis, reflect it about the x-axis, and then cut those points in half, multiply it by 1/2, you'd wind up here. Okay? You have some rules about this, don't you? Yes, you do. Okay, I'll let you brush up on those, but that just kind of, it reinforces what we did before. All right, so that's section 4.5. That's your dilations. So you've got some problems out of this section here. Notice this is the drawings they're doing when you construct a dilation, which is sort of what I did. Okay, only they're using a compass and a straight edge, and they're basically, they take the factor that if you double it, they go out there and take their segment, they repeat it, and they draw their lines that way. Yesterday, when we showed you how to trisect a line segment, that's how you would do a k factor of 1/3 or a k factor of 3. Okay? All right. And then once again, here's your assignment out of 4.5. Now, I'm going to post something a little different here. I got pretty carried away on 4.5 and did a whole bunch of problems. I'm not going to have you do that many, so kind of wait for this one for Google Classroom. But you can bet that you'll probably do about the first one and then like 2 through 22 even will probably what I post out there. But again, I haven't got that one done yet. I wanted to give you some notes first because I really want you to go through the examples before you try to do these problems. Because it's not just something you're just going to sit down and crank out. They actually take a little thought, okay? So I'm encouraging you. Look at the notes. Look at the videos. Read the examples. And then I'll get your 4.5 posted out there for you. All right. I would like to thank those of you that are actually doing the assignments. You're doing a great job. However, I can definitely tell the difference between people who are doing the work because their assignments are, 2.5 pages. And for those of you that are just simply copying the answers down, you're cramming them on about 2/3 of a sheet of paper. Now, I can make a prediction here. I can estimate some test scores based on what your homework looks like. So, please don't fudge it. So, it's up to you to check your work. I mean, that's how your homework's getting graded. You are comparing. So, I'm going to hold off on these notes for a little bit on 4.5, posting the answers. So please read the examples, look at some of the problems, watch the videos, and we'll go from there. All right, May's out.